Okay, so today we are going to determine whether triangles are actually similar. And what you should have gotten from yesterday's work is that shapes that are similar, their sides are proportional and their angles are equal. All right, so when you look at triangles, all right, let me see how you can tell. All right, if I were to ask you about, so the reason why I like the iPad. Do we know those are similar?
Yes.
Why?
Because they're flat.
You actually know is correct. They look similar, right? But there's no way to tell. All right, so what was one of the rules for similarity? If the angles are congruent, right? And the sides are what? Proportional. All right, well, there's two ways. Well, there's more than two ways, but today I think we're going to study two ways that you can tell, all right, if triangles are similar, right? One of them, and again, remember, this only applies to triangles, or it only applies to triangles, because think about a square and a rectangle. Are squares and rectangles similar? No, because their sides are not proportional, correct? Are their angles equal? Yeah, the angles are equal. So it doesn't apply to other shapes. This only applies to triangles. All right. Now, if I tell you that this angle here is equal to this angle here, then do we know that the third angle is congruent? Yeah, because we said that's a third angle theorem. So in a triangle, triangles are similar if two angles are congruent. All right, so the rule here is angle, angle, and then what's this squiggly line mean? Similar. So we say angle, angle, similarity. All right, so that is one way to show that triangles are similar. All you have to do is find two angles that are congruent, and as soon as you find two angles that are congruent, then the triangles are automatically similar. That's how easy. Super duper easy. All right. So here we go. Question number one. Determine whether the triangles are similar using angle, angle, similarity. So are those triangles similar? Why are they similar? Okay, so we can do vertical angles. What else? Yay, alternate interior angles. All right, so we can mark this congruent to this. Now, not the hard part really, but sometimes kids mess this up. Write a similarity statement. Why do they say write a similarity statement? Because there are multiple possibilities, right? But what I always like to do is I like to write them in alphabetical order if I can. So what I'm gonna do is I'm take this left triangle and say that is triangle what? Well, let's try alphabetical. X, Y, Z. Now, does the one on the right necessarily have to be in alphabetical order then? No, right? Because you are saying what corresponds. So triangle XYZ is similar to triangle. Now, X corresponds to what? Most people just say V because it's on the top. But that is not true. X corresponds to what? W, and then Y corresponds to, and then Z corresponds to, yes. That's how simple. Come on, guys. It's really, really simple. Really simple. Yes.
How do you know the sides are proportional?
We don't. No, we do not. That's a good question. Listen to me. Here's a rule. right? As long as the angles of a triangle are congruent, then the triangle itself is similar, which means that the sides are now, we can say they're proportional. That's what they're going to get to. All right, it's kind of like the CPCTC stuff. All right, once we prove the triangles have congruent angles, we can say that they're proportional. Very simple, very, very simple. All right, so now let's look at number 2. All right, what are we thinking here? Why? 41. So that means angle B is the what's the measure of angle B? Yeah, so just put a 41 there. And then over here in D, we can put a 49. And so now the triangles are congruent by angle similarity. So the triangle on the left we'll call what? Triangle ABC is similar to triangle. So A corresponds to F, B corresponds to, and C corresponds to, yeah, I just think that's easy. All right. So now over to number 3. Right, so angle A would be how much? 50 what? Come on, guys. 52 degrees, right? Is everybody okay with that? And then angle E we'll just say is what? 33 degrees. So are these similar? No. That's how easy. All right, very, very easy. Again, question number 4. Are these similar? Yes. So this and this looks like 2 and 2. So I'm thinking automatically yes. All right. So again, the triangle on the left we'll call triangle ABC is similar to triangle. Be careful. What is it? DEF. Now's the time to speak up. Any issues? Morty.
I have a question on number 1. How do you know that X corresponds to W?
Good question. X is the alternate interior angle of W, right? And again, I always tell kids, sometimes it's harder to see. So I always tell them, don't be afraid. There is your parallel lines, and this is your transversal. And I say that even on tests, when you're taking the test, if you can't see something, extend the parallel lines. And to me, it's easier than to see, because that's the one that's easily missed, is the alternate interior angles. Kids switch them up. All right, so let's look at number 5. It says in the figure AB intersects DE at point C, which additional information would be enough to prove that triangle ADC is similar to BEC? So right off the bat, the only thing we know is what? The vertical angles. That's all we know. All right, so in order to prove similarity, I just need what? One more angle, right? So what is it? So wait a minute, I'm gonna look at A. We're just gonna do it right in order. Angle DAC, this guy, is congruent to EC. Does that make any sense? No, that doesn't make sense. Did everybody see that? Now, we really can't talk about the sides, right? The sides aren't going to be of any help, I don't think. Let me just draw it just to make sure. AC. and BC are congruent. Does that help at all? No. So B is no good. Now, what happens if AD, for some strange reason, is parallel to EB? Yeah, there we go. Just saying CBE is a right angle, does that really help? Just saying CBE is a right angle does not really help, in my opinion. Because we have to know that this over here is a right angle. Then that would be good enough. All right, so that was kind of easy. Anybody have any questions with that? Okay, now we have to identify the similar triangles, and then it says find each measure. If they are similar, then their sides are what? Proportional. That is correct. So in question number 6, are they similar?
No, wait.
Uh-oh.
No, because the angle doesn't line up. Because the 49. Or no,
We can say that 49 degrees is equal to 49 degrees. Therefore, they are what? Similar. The triangles are similar. Now, the hard parts, right? You have to tell me what corresponds to what. That's why I think it's important to write the similar triangles. All right, so on the left, we're going to say triangle XYZ is similar to what?
Triangle JLJ.
X. X corresponds to what? J. And then I said Y. Y corresponds to what? There you go. Everybody okay with that? All right, so now I like to write the proportion with one triangle. So I say 5 over Y. And the reason why I do that is because to me, it just is easy. So XY corresponds to what? XY, look at the similarity statement. XY, now that's how you, to me, you can be deceived using the shape, using the figures. I'm trying to say use the similarity statement. All right, I'm trying to say use the similarity statement, which is talking about this up here. All right, I want everybody looking at that. I don't want you looking here. I want you looking at the statement. So I said XY. So XY, if you're looking carefully, corresponds to what? So what is JK? 4 over. And then I say that the Y is XZ. So XZ corresponds to what? JL. And JL is what? 5. So once we have it set up, you know I don't care. Everybody should be able to look at that and just say Y equals 25/4, right? Everybody okay with that? Remember, I'm just trying to show you how if you only look at the triangles, you can get them mixed up. You can get the sides corresponding parts mixed up. Yes. How did I get what? What's 5 times 5? Yeah, all it is cross multiplying dividing, solving a proportion. Everybody good on that? Okay, so now here, question number 7. And like I said, I think personally these are super important because a lot of similar triangles are on the tests, on standardized tests. All right, so now the question is, now here, how are the triangles similar? But how do we know they're similar though?
Inside the other one, and then that, well, angle F is congruent.
Yes, angle S is congruent to itself. So again, let me just show you, my personal opinion a lot of times is that when you're doing these problems, and I'm just speaking to those of you guys who want to do better as far as grade wise. If you're having a little bit of trouble seeing things, I'm totally okay with that. X5. All right. Now what I'm going to do is I'm going to move this over here out of the way. And then what I'm going to do is I'm going to construct here the smaller triangle. And then I want you to be able to see that in fact, how do we know they're similar? Yeah, because they share two angles, correct? All right, sorry, I'm plugging in my iPad. All right, so again, hold up now. Tell me, everybody's okay with that, correct? Bless you. Because we know that angle S is congruent to itself. That's how we know those are similar. Now, everybody should be able to look and say, well, RS, or I'm sorry, VS is what? I'd want everybody to look at that and just say, obviously it's what? We don't have to do any work. Wow, maybe I'm wrong. How do I know it's 20? How do I know that?
12 plus 3.
You can set up a proportion, but you don't really need to set up a proportion if you're observant. How do I know that? Yes, you can do it that, but there's even an easier way. What's the easier way? That is absolutely 100% true. But to me, what's the easier way? What? Tell us, Charlie. No. Look. Oh, what's going on? Look right here.
Oh, 12 plus 8.
Why 12? Addition is not proportional. What?
So, like, 1 times 3.
Yes, thank you. That's what you're looking at, guys. The left side and the base, it's what? 4 times larger. So if this is 5, that has to be what? 20. Now, obviously, I'm not doing a very good job. So we're going to write out the proportion. You can say, like Olivia said, 5/3 is equal to 20/x. Oh, wait a minute. 5/3 is equal to 20 over, no, sorry. I know it's right, but I just solved the variable there, sorry. So it should be 5/3 is equal to x over 12. Now remember, that's not the only way you can do it, right? You can say 5/x equals 3/12 also. But to me, I always just like to look to see if there's a relationship between the two sides. If there's a relationship between two sides, on the smaller one, that ratio or that has to be exactly the same. Is everybody okay with that? Any issues on that? All right, they can be tricky. All right, so number 8, a cell phone tower casts a 100-foot shadow. At the same time, a 4-foot 6-inch post near the tower casts a 3-foot. Well, that's kind of silly because we have to convert them to just what? Feet. All right, so if you want, you can say something like, here is my tower that's 100 feet and it casts a what? Shadow. Now, I know this is going to sound really silly, but the shadow is where? On the ground. All right. I don't know why I have to say that, but sometimes kids are like, why did you put it there? All right. Here is the height, which is 100. And then there's a what? It says a cell phone casts a 100-foot shadow at the same time a 4-foot 6-inch casts a 3-foot 4-inch shadow. So this is the person's height. This is the shadow. So if you're 4 feet 6 inches, you are what? Yeah, you're short. 4 0.5 feet. All right. And what's 3 feet 4 inches? Yeah, or we could say 3 1/3. All right. 3 1/3. What's the matter?
So what is it?
That's what I said. 100. That's why I was laughing at people who don't know where the shadow is. All right. There you go. There's your shadow. Thank you, Sam. All right. So here we go. 100 feet here. And I'm looking for the height of the shadow. Believe it or not, that is really how they used to calculate heights. All right. Simple proportions. All right. And then they learned trigonometry, which I'll show you soon. All right. So now it is a proportion, right? So we're going to say x over what? X over 100 is equal to 4.5 over 3 1/3. Yeah, I don't care, but I want exact. All right, I want exact. All right. And 3 1/3 is the same as 10/3, if you're not sure about that. There's also the alpha y equals, and it types in as the fraction 3 1/3. Right? There's so many ways. You should make sure that you know how to use your calculator. All right.
Oh, so the answer.
Now, let me show you something else over here too, guys. Everybody look up. I want to show you something. What's another way, instead of cross multiplying and dividing, what's the easiest way to solve this? Which I never understood why people didn't see this either.
Multiply by X.
Multiply by what? No.
100 or X.
Multiply by 3. Thank you, Harris, for that brilliant analysis there. Just multiply by 3. What are you talking about? Multiply by 3.
Multiply by one of them. It's either 100 or 300.
Tell me which one.
Well, I already said 100. You said
I'm
100.
trying to solve for x.
So 100.
So just multiply by 100. I never understood why that's an issue either. Multiply by 100. You don't need to cross multiply and divide. So now somebody tell me what 4.5 times 100 divided by 3 1/3 is. So 135 feet. Anybody else get 135 feet? So the tower is, in fact, 135 feet tall. Yeah, we believe you, Sam. Any issues? Everybody okay? 135 feet. What? That's what I'm saying. I want to make sure you know how to use your calculator. Or I'm not saying you have to use your calculator. I'm saying you should practice. Make sure you can do the proportion. All right. Make sure you can do 3 1/3 on your calculator. Anybody have any issues now? All right, here we go. Let's take a look at number 9. All right, it says determine whether the triangles are similar. If they are, write a similarity statement. Wow, so there's lots of triangles here, but they're asking you specifically about triangle ACE. So ACE is the big triangle here. And then we are talking about BCD. Oh yeah, so that one's not too hard to see. So that's the top. So what are we thinking about that?
Yeah.
Why?
Because easy.
They both share C.
Yes, thank you so much. That is correct. They both share C. All right, that is true. All right, they both share C. Now, how do we know that D is congruent or this angle up here is the same as this? How do we know that for sure? Yeah, they're corresponding angles, right? But how do we know those are parallel though first? Yeah, because this right here, very good. This right here. All right. If the corresponding angles are congruent, the lines are parallel. Yes, read. Oh, I'm sorry. That's all right. Everybody good with that now? So that is yes. All right. And we say angle, angle, similarity. I think they're setting you up for a couple of proofs maybe. All right. So yes or no in number 10?
Yes. I mean, I was thinking about
Sam, which one? Yes or no? You can't say both, yes and no, and then expect me to believe you're correct.
yes.
What are you thinking, Sam?
said yes.
I don't care what he said. I want you to tell me what you said again.
I said yes.
You said yes. Anybody else say yes?
I say no.
Those who agree with Sam, this is hard. I know it's hard. All right, to agree with Sam. Brady, are you saying yes?
Yeah.
All right. Brady is always correct. Karina, what are you thinking? I know it's, oh, you're saying yes because Brady says yes.
I'm saying no.
Uh-oh, hold up. Here is the real explanation. Kenzie is taking you guys down. Go. Wow. Wow.
It's a no. We don't know. No.
Brady, or not Brady, Morty.
We don't know the
It's taken me what? How many weeks before you could say something smart? Wow. Wow. Here we go.
Is it no or yes?
Do we?
I thought you were talking about number 9.
Oh, okay, Sam. Right. Who in here believes that story? Bo.
Yeah.
All right. So you see who your real friends are, Sam. Bo believes you. However, tell us about it one more time. Shh. Yeah, it doesn't say they're parallel. All right. Because we don't know that BC is parallel to DF, we cannot say that they are similar. Wow. Okay. Wow, Morty. Man. How do we know what? Brady, I'm sure you thought you were talking about number 9 also, right? Yeah. Oh, okay.
I was talking about number 9.
Yeah, Sam. All right.
You said, so are the triangles similar? And I was like, yeah.
We said that 10 minutes ago. Sam, I will let you redeem yourself. Number 11, are they similar? Sam, seriously.
Yeah.
Why?
Because there's a right angle between U and X.
He is correct. Angle, similarity.
Wait.
That was number.
Hold up. I'm eyeballing it right. They just flipped it.
Wait a minute. Stop. Hey, no, not yet. Not yet. Let me get some control. Sam, would you please tell me why they are similar? Shh.
Because all right angles are congruent.
Yes.
Here are congruent. And then U and X are congruent.
Right, guys, I don't know what y'all are waiting on. Oh, okay, hold up. Brady, is it possible for you to be wrong twice in one day?
He's wrong.
Shh.
You just flipped it up on.
Okay, hold up a second. All right. That's part of the reason why I like the iPad. Here we go. All right, here we go. All right, here we go. Copy. Here we go. Shh. This is the beauty of this. Wait, just stop. Wait a minute. Uh-oh, I'd have to reflect it. So I can't. But anyway, you can see it. I wish I could. I wish I had the ability. Maybe I should tell them. We should be able to reflect that, right? So look, now again, I'm trying to show you something, and I appreciate this because it's the first time I can see why some of you guys are struggling a little bit. All right. Some of you guys are struggling a little bit because you're not just focusing on two angles that are congruent. All right. So if two angles are congruent, then the triangles are proportional. So some of you said rightly so, this is a right angle, that's congruent to that. One tick mark is telling you that this is congruent. So yes, they are similar triangles. It doesn't matter if they're not matched up perfectly. That's what makes it deceptive. That's why some of you are going to mess up the test, because your eyes are trying to focus on what it looks like rather than just looking for the ways to prove that it is similar. So we know that we'll go with the top triangle. What is the alphabetical order? Triangle.
W, X, Y, V, W, S.
V, I know, I have to do that too. I have to say the alphabet. VWX is similar to triangle. So V corresponds to what?
T.
T. W corresponds to
U. V.
V. And X corresponds to what? U. Now look, I'm saying, I'm trying to tell you guys, right, where the mistakes occur. And this is the mistake. I think every time you solve a proportion, you should write the similarity statement, because you can be deceived, right? Once you draw the similarity statement, it tells you V corresponds to T, W corresponds to V, X corresponds to U. Then you can say VW over TV is equal to WX over VU equals VX over TU. There's your proportions. Does everybody see what I'm doing? All right, I'm not looking at the triangle. I'm looking at the similarity statement to write the proportions. That's all I'm doing. All right.
So if the angles are equal, is it always similar?
In a triangle, yes. If two sides are congruent, or if two angles are congruent to two angles in another triangle, then they're automatically similar. That's what this is saying up here. That's what we said, angle similarity theorem.
Okay, but if it's not a triangle.
It's not a triangle. And that's why I said at the beginning of class, think about a square and a rectangle. Square and a rectangle are not similar, even though the angles are what? The same. You with me on that? All right, but a triangle, that is always true. If two angles are congruent, the triangles are automatically similar. All right, so let's get down here.
I don't think we should.
Determine whether the triangles are similar. So obviously everybody knows now, because those are parallel lines, they are what? Yes, there's corresponding angles involved, so we know that they are similar. So the small triangle, we're going to call what? Triangle JKP is similar to triangle
Probably
JLM. Now, again, remember, sometimes it's good to write the corresponding angles. All right. And that way you don't make a mistake with writing the similarity statement. Just like over here. All right. In 13, is it possible? Yeah, it's possible that they are similar, but do we know it? No, because we only have what? We only have one angle. So there's no way to tell for sure. There's no way to tell for sure. All right, now let's look at 14. Well, to me, it's easy to say no unless you figure out what the third angle is. What is the third angle?
I mean, it's gotta be
65.
What is it?
65.
Yeah,
Is it 75?
and then the other one.
It's 65.
I don't know why you guys, come on, guys. Give me some good information. Thank you.
We're so good. We're so good.
The other one's like 70.
Wait a minute now. I'm not, is that correct? Is angle R 65? Right, so do I really need now to figure out what U is? No, because 47 is equal. So the only way it can be equal is if this is what? 59. That's the only way they can be similar, right? So as soon as I find out 65 is not equal to 59, then I know they're not similar. All right, so that's a no also. All right, now again, honestly, the last part here is the most important part. All of the word problems and solving is really important. All right, so here we go on this. All right. So
Yeah.
again, yeah, these are definitely similar. So what we're going to do is we're going to do the one on the left, which we're going to say triangle CDE is similar to triangle. Now C corresponds to what? F. D corresponds to, and E corresponds to E, yes. All right. Now I just like to look here and say X over 6. So I just put down X over 6 is equal to, now EG, right? EG corresponds to DE. So DE is what? 10. And then 6 is FG. So FG corresponds to what? CD, which is 15.
Yeah.
What? What? Thank you. I don't really care about this figure. It can be distorted a little bit. Trust me. All right. When I take pictures, sometimes it's distorted. What's the matter?
Since CD is, or ED is 2/3 of CD, then wouldn't X be 2/3 of X?
Yeah, I honestly, I don't really care how you solve it, truthfully. Right. I'm 100% agreement with you. Yes.
I don't understand how UV
Say it again. You don't understand what?
I don't understand how GE corresponds to DE.
Because I wrote the similarity statement. And GE up here corresponds to DE. That's what I'm saying. I don't really look at the figure because the figure can be twisted and reflected and it can be very deceptive. All right. That's why I'm trying to tell you, setting up the proportion is the most important thing because everybody can solve a proportion. I don't have any doubts about that. All right. So now number 17. All right. They're parallel. So we can say that triangle QRS is similar to triangle what? QPT. That was straightforward. So now we can say X over 12 is 20 over 16. The right side to the base is equal to the right side to the base. Is that the only way to set it up, guys? No, it's not the only way to set it up. Not probably. It's not. All right. You don't have to write it the way I'm setting it up. You have your own way of looking at the picture. I have my way of looking at the picture. All right. You just have to make sure that the corresponding sides are written properly in your proportion. Hopefully that makes sense. All right. Now, are these two triangles similar? Yes, because we can just make this right here. All right. Now, again, I think this is a good problem because you have to be careful with the way it's written. So the triangle on the left, we're going to say is triangle what? UWZ is similar to triangle. Now, U is the right angle, so that's U. W has one tick mark, so Y has one tick mark. Z has no tick mark, so W has no tick mark. That's how you should be thinking about it. Does anybody have any questions with that? All right, now I like to say 30 over 30 or 32 over 40. So I'm putting 32 over 40. And then I say 32 is UY. So I find UY. UY corresponds to UW. Uh-oh. Does that help out? Did we write that similarity statement correctly? Well, I'm saying, I'm trying to show 32 is UY, correct? And UY, we said corresponds to what? UW. So you're Sam, I'm asking, you can do anything you want. I'm saying, is it correct? You just said 32 over 40. What does 32 correspond to? I'm asking, Sam, do you agree with that or not? You sure? So 32 corresponds to UY. So I'm saying I looked up here at UY and said UY corresponds to what? And I thought, well, there's no value for UW. Yes, there you have it. That's exactly correct. All right, now I'm trying to tell you that's how deceptive they can be. Does everybody see that? Right? We know it's a right triangle. All right, so because we know it's a right triangle, a squared plus b squared equals c squared. So now remember, this is 8 times 5. This is 8 times 4. So this is 8 times 3. 3, 4, 5 triangle. I'm going to do that over and over and over to try to convince you. All right, so I already know UW is what? 24. So 32 corresponds to what? 24. And then 40. What is 40 correspond to? WY corresponds to, or WZ, or ZW, however. But that is what? Yes, 3x minus 6. All right. Now, I want everybody to cross multiply and divide and solve that, please. Someone tell me what x is. I'm not doing the work. Everybody's doing the work. Olivia, go. What? I did a squared plus b squared equals c squared. Right? Now, do you remember me talking about triples? 3, 4, 5. So I just multiplied that by 8. 24, 32, and 40. So the other side is 24. Now look, guys, I don't want someone else telling you what the answer is. I said, tell me what x is. Morty, what is x? You act like you're done. Come on. Don't tell me you have no clue. It's a proportion. I did that in my pre-algebra class. Tell me. No, come on. Of course it's right. You're saying the answer. Somebody said 12. What'd you get? 12. Harris? Yeah, you haven't been right all month, so do that again. Go. How much? 12. All right, so I'm going with 12. I'm definitely not going with Harris. 12, right? And if you can't get 12, you can say, hey, now look, what I'm trying to show you on these now, you have a calculator. Come on, take out your calculator. Let me show you how simple it is. All right, everybody, I want to be able to do this. All right, so take your calculator. All you have to do is 24 times 40 divided by 32. Hit the equal button. Plus 6, hit the equal button. Divide by 3, that's the answer. Right, you should be able to mentally do that. 24 times 40, then divide it by 32. Then you have 3x minus 6 equals that number that you have on your calculator. Then it's just what? Add 6 and then divide by 3. And of course, x equals what? 12. Now that we know x equals 12, then what's ZU? 18. So UZ equals 18, and then it's asking for WZ, which is equal to what? How much? Anybody have any issues with that? Nobody? Nobody's having issues. All right, so please do me a favor, guys. I think that's a good spot for me to stop. That means I want you to try to do 19, 20, 21. And again, I don't care about 25, but I do want you to do what? I do want you to try. The word problems are the most important parts. Those are the things that are on the SATs and the ERBs. All right. Now, 19, 20, and 21 can be deceptive, so you got to be careful. Now, I want everybody to look at 21 for a second because I don't like this picture. Look at 21. What exactly is this right here talking about? Angle what? Yeah, angle what though? Angle D is congruent to what? Yes, he's correct. Wow, 2 things in one day. Right? You see what I'm saying, guys? And so does everybody see? It's the big triangle and the what? Small triangle. And so what I'm trying to tell you is a lot of times when I do these problems, especially on my iPad, I just draw the triangle and then I remove it. And then I draw the small triangle and remove it. Then you can see the corresponding parts better. All right, if you don't do that, you're just going to make all kinds of mistakes. Last year, I can remember, that's the reason I thought about it for a second. Kids are like, I don't know what that means. Right? That is not saying this angle right here is equal to this angle. That's not what it's saying. All right, be smart. All right, my homeschool peeps. Again, remember, the finish, the only thing I don't really care about is number 25. All right. Hopefully you're good. Tomorrow, this whole chapter is all about proportions. All right, which I think is very easy. All right. So you guys have a great day, okay?
Bye. Thank you.
Take care, guys. Bye, guys.
Thank you. Bye.
Goodbye.